So, hello, this is MD Mahabubur Rahman. So, our project is the comparison between PyTorch and TensorFlow for the machine learning. So, first, if we want to talk about the objective or of our project, that is the using two data sets where one is fashion mist that is for image classification, and another is in our equifair data set that is mainly for regression model, using different kind of like multidimensional arrays, learning coding in both environments, and comparing the PyTorch and TensorFlow at all. And the criteria, if we want, I want to talk about the criteria, what actually we have used in our comparison. That is, we have used the same type of data set, same number of epochs, same number of layers, number of nodes, with the associated activation function, same optimizer and hyperparameters, same loss function, and also the we use the execution time, how much time actually it takes for running these codes into both PyTorch and the TensorFlow.
Hello, my name is Azucena Lopez. I will be talking about the criteria for comparison between PyTorch and TensorFlow. To do this comparison, we run the code with the same dataset to get the accuracy and the running time. To get the accuracy, we made some modifications to the coding, like we use the same dataset that is called fashionist, that it's in the PyTorch and TensorFlow. We use the same number of epochs, which are five. We use the same number of layers, same number of nodes with associated activation function. We used also the same optimizer function that is SGT, and the same hyperparameters with the learning rate equal to 0.001, and we use the same loss function. We also added the time set, and for the running time, we execute the CPU time. So we made the modifications to all the code in, well, not all the code, but in part of the code in TensorFlow, trying to do the same that we did in the code in PyTorch. So if you can see here the results in your left is PyTorch. Um, the same, we use the same number of layers and number of nodes, that is 512, if you can see in the left in PyTorch. And in TensorFlow, we added a layer dense with the number of nodes 512. We also added the dropout function in both of them with the with zero point 0.2 in dropout, and we also have the same loss function with cross entropy, and the same optimizer function, which is in SGT. And if you can see, the learning rate is equal to 0.001 in both of them. So after do these modifications to our coding, we got the results in PyTorch. The accuracy was 64.7% and the loss 1.007. And in TensorFlow, we got the accuracy of 80.16% and the loss about 0.59. And also we got the execution time CPU in PyTorch 653 seconds, and in TensorFlow we got the CPU time for 0.98. seconds. If you can see also memory usage in PyTorch is 87% and in TensorFlow it's 88%. So we can see these results. It's more convenient to use TensorFlow because of the accuracy that it's 80% and the CPU time it's less than PyTorch and also the loss is less than PyTorch.
Good afternoon. My name is Zaki Ahmad Chaudhary, and this time we are going to compare the two frameworks using a regression model. For a regression model, we used the fluoride content data of Ogallala aquifer. Now, the regression model is different from the image classification model in a number of things. Firstly, in terms of data set, we had a prepared data set, but now we'll prepare our own data set. However, this time we had to use different functions for splitting, and the split ratio was 80 is to 20 for both these frameworks. We used normalized the featured data and to compare the performance, since the programs needed to use same hyperparameters, so we used same hyperparameters for 7 features and 1 level, and that data from 933 wells. We prepared 2 layers, one with 7 inputs and 32 nodes using the ReLU activation function, and the second one is 32 input nodes and 1 output node. So in total, we have 258 weights and biases. So this is enough for 933 data. And we really don't think that it permits adding more layers. The loss function we used was mean square error, and optimizer used was Adam. Learning it was 0.001. And finally, the result for TensorFlow, the testing didn't produce a desired output, but the time taken for program using TensorFlow framework was 6,890 milliseconds. And for the PyTorch framework, everything from the training part really didn't go well, but the time taken was 2390.625 milliseconds. So that's all from our side, and thank you.